The return of a wave back to its original medium is called reflection. Attach a spring to a wall and send a pulse along the spring's length. The wall is a very rigid medium compared with the spring, so all the wave energy is reflected back along the spring. Waves that travel along the spring are almost totally reflected at the wall. If the wall is replaced with a less rigid medium, such as a second heavier spring, some energy is transmitted into the new medium. Some of the wave energy is still reflected. The incoming wave is partially reflected. Materials like glass and water are not as rigid to light waves. When light shines perpendicularly on the surface of still water, about 2% of its energy is reflected and the rest is transmitted. When light strikes glass perpendicularly, about 4% of its energy is reflected. Except for slight losses, the rest is transmitted. In one dimension, reflected waves travel back in the direction they came from. In two dimensions, the situation's a little different. The direction of incident and reflected waves is described by straight-line rays. Incident rays and reflected rays make equal angles with a line perpendicular to the surface called the normal. The angle between the incident ray and the normal is the angle of incidence. The angle between the reflected ray and the normal is the angle of reflection. The angle of incidence equals the angle of reflection. This is known as the law of reflection. The law of reflection applies to both partially reflected and totally reflected waves. If a candle flame is placed in front of a flat mirror, which physics types call a plane mirror, rays of light from the candle are reflected from the mirror in all directions. Each of the infinite number of rays obeys the law of reflection. The rays diverge or spread apart from the tip of the flame and continue diverging from the mirror after reflection. These divergent rays appear to originate from a point located behind the mirror. That's why you perceive the candle flame to be located behind the mirror. A virtual image appears to be in a location where light does not really reach. Plane mirrors produce only virtual images. Your eye can't ordinarily tell the difference between an object and its virtual image. The light enters your eye in exactly the same manner as it would if there were really an object where you see the image and fools your brain. The image is the same distance behind the mirror as the object is in front of it, and the image and object are the same size. The law of reflection holds for curved mirrors, but the sizes and distances of object and image are no longer equal. The virtual image formed by a convex mirror, a mirror that curves outward, is smaller and closer to the mirror than the object is. Some convex mirrors have the words "objects in mirror are closer than they appear" written on them. Why do the objects appear farther away when the images are actually closer? The reason is because our brain interprets smaller objects as being located farther away. This phenomenon is known as perspective and is used by artists to create depth in two-dimensional drawings. When an object is close to a concave mirror, a mirror that curves inward, the virtual image is larger and farther away than the object is. Concave mirrors are often used to magnify objects like a mirror version of a magnifying glass.